Find the arc length of f of x, given that f of x equals e to the x plus e to the negative x over 2 for 0 less than or equal to x less than or equal to natural log of 2. Okay, so we do our arc length formula. So arc length formula is delta x squared plus delta y squared square rooted. This is the Pythagorean theorem. And we'll integrate it, factor out a delta x. So we have a delta x squared square rooted times 1 plus delta y over delta x, this is a y, squared, square rooted, still integrated. And then to formalize this, the delta x squared becomes dx. So we have 1 plus, I'm going to say f prime of x, because f prime of x is basically dy dx. And this will be squared, square rooted dx integraled. Yeah, except for that radical, this looks pretty reasonable. There we go. Now I'll stick with the same color blue. There we go. Much more pointy. Okay, and so here's our formula that we're going to work with. So, first we have to find f prime of x, and from f prime of x, we'll find f prime of x squared. Then we'll integrate. Okay, so we have f of x equals e to the x plus e to the negative x quantity times 1/2. F prime of x then will equal 1/2 times e to the x minus e to the negative x. So what happens here is, we're doing substitution. So for the e to the negative x, we are going to, it's going to be e to the negative x, but then it's going to be divided by divided by the derivative of the exponent in this case. And in this case, the exponent is -1, so we're dividing by -1. That's why we have this negative sign right here. Okay? So then we need to square this. So we have f prime of x squared. So we'll have 1/4. And then we're going to have to square e to the x minus e to the negative x times e to the x minus e to the negative x, appropriate parentheses. When we FOIL this, we'll get something along the lines of e to the 2x plus 2e to the 0, or is it minus 2e to the 0? Minus 2e to the 0 plus e to the negative 2x. There we go. This e to the 0 then just becomes 1. So we have 1/4 times quantity e to the 2x plus e to the negative 2x. And now this is where we're going to plug this into the formula, change colors to show our train of thought derailing, jumping the tracks. And we have integral of 1 plus, wait a second. Okay, we also have a -2 in here. There we go. Let's see. E to the 2x over 4 minus 2 over 4 plus e to the negative 2x over 4. Okay. Square rooted dx. And now we're going to have to do a little bit of algebra. So the key point here is, get my canceling color, green. Turns out the canceling color is just a different color that contrasts well. So this 1 minus 2/4 is the same as 1 minus 1/2, which will actually just give you 1/2, like that. You'll see this kind of happen a lot with arc lengths. Arc length problems are kind of set up to kind of do this trick. I say trick, but you'll see this whole 1 and the FOIL common middle term kind of have some synergy between them quite often. But what often will happen is the sign will just reverse. Inverse the polarity, so to speak, in the Star Trek world. Okay, so we have 1/4 times e to the 2x plus 2 plus e to the negative 2x square rooted dx. And this will, when we simplify this, this will be 1/2 e to the, wait a sec, can we do this? To the x plus e to the negative x squared. So remember the foiling we did earlier up here where we got this 2e to the 0 term? If we go backwards, we'd get the same thing, except instead of having this e to the x minus e to the negative x, we're going to get e to the x plus e to the negative x. And since it's squared, we can then do the square root of it. Pretty straightforward. So we just have 1/2 quantity, so see some sort of quantity there. There we go. E to the x plus e to the negative x dx. Move this 1/2 outside. This gives us, let's see what our limits of integration are. 0 to natural log of 2. So then we have 1/2 integral of e to the x will be e to the x up here I said we divided by the derivative of the exponent. I should have actually meant multiply because this is a derivative, not an integral. But it'll actually end up being the same. So we'll have e to the x minus e to the negative x. Now this is actually substitution. Up there it was supposed to be the chain rule, which the chain rule and substitution are inverses of each other. Okay. Enough of a tangent. Tangent ended. Okay, so we have e to the x plus e to the negative x. When we do the integral, we get something like this, and we'll integrate from 0 natural log of 2. So now we just plug in numbers. So we have 1/2 times quantity e to the natural log of 2 minus e to the natural log of 1/2. So what I did was I just took that, so we have e to the natural log of 2, negative natural log of 2. That negative, they can just go up and become an exponent for the 2. And 2 to the negative 1 will be 1/2. I write it this way because it makes it look easy on how to do the next step. Minus 1/2 e to the 0 minus e to the 0. Yep. Which becomes 1 minus 1, which this becomes 0. And we are left with 1/2 times 2 minus 1/2, which is 1/2 times 3/2, which equals 3/4. Haha! Huzzah! I'm amazed by how much work we can put into these arc length problems. Look at that. Look at that. Crazy amount of work. Crazy amount. Insane. And we even got an answer that shows up as a possibility, which is nice. So, right there, 3/4. So let's backtrack. Find the arc length of f of x. We had e to the x plus e to the negative x over 2 between 0 and natural log of 2. So we really weren't quite sure where to go, so we wrote up our arc length formula. So part of the arc length formula is we find the derivative, which we did right here, f prime of x. We then took the derivative, squared it, and we had kind of like a foiling issue, is where we got this negative 2 e to the 0, which was just negative 2. That negative 2 became negative 2 over 4, which was 1/2. And we added 1 to negative 1/2, we got a positive 1/2, which meant that we could then reduce what we got under the square root to a square, which we did right here. We then took that square rooted it, and just got the original thing back, which was nice. And from there, then we just tried and figure out how to plug in natural log of 2. Well, we took the integral, which wasn't too bad. Plugged in natural log of 2, plugged in 0, and we got a surprisingly straightforward answer of 3/4 for the arc length. So that's how you do this kind of arc length problem. Thank you much. See you on the next problem. Go team.